Hi, Michael. Yes, I can hear you. Is it time? Can we get started? Oh, okay, great. Okay, let me try sharing my screen. Just a moment. Just a moment. Okay. Yeah, Michael, confirm you can see my screen. You can unmute yourself and confirm. Just trying to be sure. Okay. Great. Thank you very much for this opportunity. Yeah, so presenting my screen. So Mike, if there's anything and you probably want to send a message across, please send me directly via WhatsApp because I won't be seeing any messages typed at the moment. Okay, so thank you very much for the opportunity once more, and thank you very much for connected who is listening to this talk either now or probably when it's uploaded or after being recorded. So this session is basically to give us a brief. Because like I'm not sure it's possible to be able to complete the whole of the explanation of what really happens, right? How everything is connected and why and why it is connected. But I'm going to do my best to explain how these things work, what's the relationship between front end and back end, what's even the difference between the two, right? And then we'll get to know what it is. My name is Awal MS. I'm a software engineer, and my specialization is on web technologies. I previously had experience with mobile apps, so I'm kind of like someone who can talk about the both side of life. And even for web, I build for both the front and the back end, but I prefer, I prefer, like, I'm not a full stack developer who builds apps that work on machines. If at the end of this session you're able to ask questions, you can ask me in the chat section, right? If you can't, please, my Twitter handle is @ms. You can go ahead and send me chat. You don't even need to follow me to be able to ask me a question, right? My DM is open. So I also support the Developer Student Clubs program at Google, where I currently manage 200 student developers who lead 200 DSCs across over 20 countries in Africa. So that's basically what I do. So let's look at what it is, right? The relationship between front end and back end. I'm giving this talk with a perception that you're just a user. You may be a front end developer, you may be a back end developer. It doesn't really matter. But let's look at this from a user perspective as well as from a developer's perspective. So when your user visits your website, he basically sees what's in the front end, right? This is what the front end looks like. If you're walking through, this is like an iceberg, but you can only see what is in. You don't know how deep it is. Basically, a user only knows what's in the front end and doesn't know what is in the back end. So what the front end is this shiny, very, very good looking part that most times you get to see. The back end is not really ugly. Most times you just don't have the view, the UI that you need, even though people build dashboards which are like the front end of the back end, right? But let's just assume this is what it is. And if you think this is not clearly enough, so let's look at this. So if you've been watching movie, you will have seen Metro Golden Mayer. This trademark here shows you a lion here, like roaring. But in the back end of life, this is what it basically looks like. This is to say this is actually what it looks like, but this should do well for an explanation. this is what the back end looks like. So you see, when you're seeing this image on a movie, you don't get to see what happens here, right? So this is the shiny part. This is the not very shiny part of the web page. So basically the difference between front end and back end. And in a nutshell, this is what really happens when you try to visit a website, right? From your browser, you go to www.google.com or probably .facebook.com, or whatever website you decide to, or if, let's say we build an app, right? For tech, and this is hitting this site via our browser. Our browser does a request, basically a GET request to a web server, right? It connects, it does a web request. A couple of things, many things really happen in between you pressing enter, basically trying to do a call, a HTTP request, get to find, okay, what is the DNS search, and be able to find the IP address and stuff like this. And then end up being like, okay, I can find the server. It visits the server is the back end of the code. And then the back end of the code is actually connected to a database. So we can even argue that the database is the back end. This is basically a middleware, right? Most times they usually tell people, so the API you're building is just a layer. You could probably assume it to be you could assume it to be like a middleware, right? Even though for people who build back-end technologies, will tell you that things they actually call middleware. But between the front end and the database, the back end itself is just a middleware that connects to the back end, to the DB and stuff like this. It's a topic for another day. There's a lot of explanation that an hour cannot be able to this, but I'm going to do my best to say my best. And this here, browser here doesn't necessarily need to be a web browser, right? When you're trying to visit a website, when you build a website, a mobile app, basically not even a website, a mobile app, you end up in something, you when you do stuff like, if it's a dynamic app, basically, say an app that enables users to chat with each other. So which basically means these users need to sign up, have a username, or possibly you're going to use their display name, so they still have to sign up. And then tomorrow when they want to chat, they need to have been logged in. Right? The user need to log in, able to know who this user is. Because you don't know, predefine the number of users on your system at the time of building. So people need to sign up and tell you, this is my email address, this is my password. Anytime I come to this website and enter this username or phone number or password, and press enter, please confirm and see, and you are able to authenticate that, okay, it is me. So show this as my display name. It will usually happen, right? It is your responsibility to build a very shiny UI, the front end, like the login page for people to enter their details, and it has to be clear to be able to know what is expected of them. So let's assume it's email and password. They provided their email address and password. It is the responsibility of your system to be able to know that, okay, it's this. If the user does not exist, you're supposed to send the person an error message, okay, username or password does not exist, and stuff like this. So you could probably, the user could probably try another password if they're sure they have an account with your platform. If they are not sure, they could probably go and sign up, or if they are sure but they cannot remember their password, they need to do a reset password, start a forgot password process, do an authentication and stuff like this. So that is basically what happened. So I kept saying you need to do a shiny UI, right? A good, like a very interesting one that users can be able to see and provide their credentials to be able to be authenticated. If you go to your school, for example, your school will definitely ask you, okay, what is your matric number, and then they probably check your name for authentication to authenticate you're a student, so you can't come and sit and write exam in a school that you're not even a student and stuff like this. So what's this front end thingy, right? That shiny UI of a thing, right? Basically, it uses HTML, CSS, and JavaScript. At least that is what it uses in the background. Like whatever you start, you know it to be using, it's just HTML, CSS, and JavaScript. Whatever you're going to use to build the UI for a browser, it's actually HTML and CSS and JavaScript, right? Even though, so for mobile, for example, you're building an Android app, you're probably possibly using Kotlin, or probably using Java, or you're using Swift in iOS, or you decide to like, okay, I'm building something with I'm building a cross-platform application with Flutter, right, or React Native, or whatever is of your choice, right? So it depends on your language, but for browser, for the web browser, it's HTML, CSS, and JavaScript. Whatever language we'll come to find out, this is what it compares back to. So this is what it looks like. But then look at this here. So the front end technology of the team has evolved since 1995. Since the beginning of time, like let's just assume the beginning of time is since we're having this conversation about web technologies, let's assume since the beginning of web technologies, right? So it's been HTML, CSS, and JavaScript. So looking down from 1995 to 2019, and I think we'll probably argue up to 2020, right? This is what it looks like. So started, it was like HTML, right? You can see it was of 4, and there is CSS. So yeah, these are the same thing, and then Flash was added around that period because people needed something, some animation, a couple of things in addition to what CSS is able to provide, right? And then as at then we had JavaScript was introduced, right? And stuff like basic animation was done with JavaScript, adding interactions and stuff like this were done then, as well as ActionScript, some sort of thing that came with mobile or Flash, right? And then at the tail end, so 95, 96, 97, 98, 99, around 99, CSS3, around 99, not sure it's actually 99. CSS3 came about. I know somebody will be like, wait, CSS3 was actually here since then. Why were we just knowing about CSS3 like recently? Well, it has been here, right? It was here since HTML5, but like just using CSS, right? And then in 2000, W3C, the World Wide Web Consortium, standardized that for HTML, and that was when it was what do you call it, HTML, right? It's an extended HTML. Basically, you could probably identify it with a very long declaration. In HTML, you see the first line you write type HTML. That is not the case in XHTML. It's one not the same as, like, it was complicated then, also complicated in DHTML and stuff like this. So this is what happened. And then Markdown came in, and then many languages from 2005, things like blew everything. Oh, people started talking about Hamel, people started talking about SAS, but never was not, it wasn't really popular, right? And then we had Dojo, one of the first few stuff like that inspired jQuery, and then jQuery came, really helpful tool, modules and stuff like this. In 2010, things got more complicated in the front end. So life between 95 and 2000 was like the best thing ever for people who were building apps then. I wasn't building. I was busy with primary school, I guess. Yeah. From 95 to 2000, like people were building things which they just had HTML, CSS, and Flash, and some JavaScript to be worried about. Markdown came, Dojo came, made things more complicated. Like not really more complicated, but make more options. So the more the options in front end, especially the more the options, the more complicated life became for people who were building up for the front end tools. And then Markdown came, Dojo, fine, prototype was great. In 2005 to 2010, a couple of things were introduced. Handlebar 2010, you could also Hamel, SAS to try to make SAS-less CSS. All these were came then. People started talking about variables in CSS. Life was just sweet when everything was just CSS. Like CSS3 was just everything for people. Like ES5 came then, tried to reduce some things, merge ActionScript left, and then like what do you call it? ES5 was helpful. Underscore tried to build underscore and jQuery, basically, if you know Lodash and stuff like this, try to make things easy for people, added more functionalities to ES5 and stuff like that. From 2010 to 2015, things become more complicated for the front end. HTML5 was introduced. Yes, HTML5 had some element of JavaScript in there. For example, you could write there are things around the video tag, the audio tag, the pictures tag, I think figure, and even the more complicated ones like I can't even remember this. Oh, damn, I don't know. There's this feature in ES6 that came with in HTML5 that enables you to be able to render drawings. I can't remember the exact name, but then things become a bit less complicated, right? But then ES5 had a lot of things, and then around this time in 2015, the 6 was introduced. DSX came about. We had a lot of CSS, a lot of JavaScript libraries within the 2010 to 2015. Angular, Backbone was here, Knockout was here to help back-end technologies with Backbone. Knockout was here in the middle of everywhere. Went to bring Angular started this life of let's remove jQuery and make things easier. We started doing what do you call it, SPs, but this was made like web components came around. It was really helpful to do this. Browsify, Webpack, Grow.God, where task managers trying to help you build stuff faster. Say what happens, basically to automate many stuff. NPM, really super amazing, help people. Aurelia, or Ember, Angular, Vue, and React were all introduced within 2010, 2015, right? Angular was first before Ember, and then around Aurelia followed Vue.js. Was around the same 2015 and stuff like this. Most of these were inspired by AngularJS and stuff like this. So that's it came and then got applied by Angular 2, right? One was one, Angular 2. Like a couple of things came. For CSS, things become better. Between Bootstrap came to life, Foundation, really great tools materialize, semantic UI, and stuff like that. It didn't just stop there. Even for CSS after stars less than CSS, types came around, CSS, stuff like this. And then JSX came to make was said to have come to make HTML much easier. I don't know, not really a fan, but things are getting better. So in 2000, from 15 to 2019, it's not like it didn't become any better, right? Like we had more additional tools. Like I think as that when JS was celebrating 20, like a few days ago, I think I saw a count around about 1 million frameworks, CSS, JavaScript frameworks. I'm not sure, but like basically it means, and then more complication, because like you will be worried about, okay, what tool should I use, what tool should I not use, or what is the best this and this. So basically a lot of things to learn, but that is how everything evolved, right? From here to here, it's how JS evolved from ES1 down to we're in ES10. God help us. But basically these are how things have gone, like growth. The same thing for CSS. HTML has been relatively less. It hasn't seen a lot of growth, right? Yes, there have been growth, but it hasn't gotten a lot of options, right? ES5 is still very better preferable for, like HTML5 is still what you prefer when you're building front end, right? So this is what the front end looks like. And remember, the talk today is not about front end, it's about how everything merged. But everything here actually helps. Like when I move to the next few slides, you get to understand why most of these were here and how to try to help life. So let's look at what an authentication page looks like. So imagine this is a website. This is imagine here. Okay, so I forgot your email address. I'm trying to probably So a user visits your site, tries to sign up. So that's this. You try to tell him, okay, enter username, password. The person clicks on submit. Already create the account. The person is here trying to log in. Provide the email address. Forgot the password. Click on forgot the password. Send the reset password. So what really happens here when the person clicks on submit, right? This everything until the click of the submit button is basically front end. The styling, the colors you see in here, everything, the animation and everything is HTML and CSS. The click of the button is where JavaScript comes into play. When this person clicks on submit, you're inviting JavaScript to make things happen. So let's simulate what this looks like. This code here looks like what we have here in the input field, not what the email the login field, right? You can see email, you can see password. This is what it looks like the same time. And then there's submit button, right? So this is basically a HTML form, right? With an ID of login form and input, we type email because we want to get the email input. And another input again, we type password because we don't want, when we're typing the password, you should be able to see. We could have used number, or could have used text, but then when you're typing the password, anyone can see what you're typing. So when you give this password, everyone sees to be able to see what you're typing, right? It just be a star or a dot, like stuff, something like that, just encapsulate what you're typing. Other than a class input, password input, as well as an ID. So like depends on what we're using, right? And then our here has a type submit. The reason why we have a button with type submit is because we want, when we click on submit button, we want to trigger something, right? We want to trigger an action. So you didn't see, so I'm not a fan of writing JavaScript in HTML. Like I told you, the same reason why I hate JSX is the same reason why I'm not writing, you didn't see me writing anything in this field besides just email and beside the tag name and this attribute, right? So I click on submit button, what happens, right? This is where we're triggering the JavaScript part of this. So you remember we had the form had a this form here. Sorry, this form here has an ID for login form. It's what we're calling here. We're doing document.query selector to get the login form and save it in this variable here called login form. And then the login form, we're adding an event listener. So when the user clicks the button, it just triggers an event. But what type of event, right? Because remember, this button is inside a form tag and it's type submit. So it means when we click on this, we mean you should submit. That's the action we're explaining. That okay, action submit. So over here, we're adding an event listener. Once basically trying to say if this action happens, when this event, the action or the event here is submit, right? We provided submit attributes. Sorry, I don't know. I didn't know when I add a timer to this anyway. So when you click on the submit button, right? This run this function, right? A callback function. And I'm using arrow functions here. I don't know, probably you've been taught about this, maybe you've not been taught, maybe you'll be taught later. But I guess you learned some front-end technologies. An event, basically something really happens, normally happens. So you click on the submit on a button on a page, the page is usually supposed to preload. So for me, I'm taking the event, but what's the right word to use? So I'm taking this event as a parameter, and to prevent. So the default video is to reload, right? I just told it, okay, prevent default, so don't reload. Just act as if you don't know what happened. So if we didn't have this, anything, it's just going to act as if nothing happened, right? You click on the button and the button won't show you to reload the page. In one day, when you click on this, the first line of action after prevent default is to show you a loading bar, right? Just like what we saw in this case when the user clicks on forget password, right? The same thing that happens here. That's the normal thing it's supposed to do. But well, I didn't cover that in this part. I just wanted to show you the basic things. So like every other thing here is just it's just beautification, but what we're trying to, we're not doing a CSS class or HTML class or front end class basically. But basically after taking prevent default here, we get the email, right? Document query. Go to the form, like the form that this CSS, this JavaScript file is attached to, and find an item with the email with the ID email input and get the value for us. So and then save it to the email place, what do you call it, variable. You basically know what the variable is, the placeholder where it's saved and things like that. And then go to the password, do the same thing, get what is the value in the password input field, right? And then basically what is checking if the email and password is not empty, I wouldn't need to write email is equal to empty string or like this. So just check the email and password, basically checking this and this. If they are not empty, call this function called authenticate user and pass the email and password to it. But in a case whereby, in this case here, whereby this is not correct, either the email or password is not it's empty, either one of them or both of them are empty, send this to the what do you call it, to the console. On a normal day, you're definitely going to show it back to the user. So this is just for test sake. And even to be able to check if this email and password, you could probably even cut this out by just adding required to this field. If I will have added required, it will have gone to the next line, and I just want this to be like as short as this. I wouldn't want you to be worried about HTML and stuff like this. So, but basically this is still JavaScript. We're still trying to, these are things that are happening when you submit, right? JavaScript usually is, what JavaScript is known to do is to add behavior, right, and interaction to a site. So you call that authenticate user. We already have an authenticate users function here, right? You can see this function, I don't know, possibly you thought function expression and function statement, but this is what it is. I'm passing a function down to a variable here. So, and then you remember here, we're passing email and password as our field, and it's the same thing here. So the authenticate user is expecting email and password, right? And then in here, we're doing an arrow function where we're taking this kind of anonymous function, if you know what it is, like the body, right? We're using template variables here, or template literal, whatever you call it. And then take email is equal to this and password is equal to this. I know somebody on this call will possibly be arguing, you should have used JSON and password update, email is email, password. I know, I don't say this field. This should be easier for you. Literally anyone that works for you, depending on what your back end is expecting. And then this is what really the front end to the back end. Here, we are at this point in time, after getting everything we need, we now want to connect to the back end. And we didn't save the user's front, we don't save the person's email and password. We don't have access to a database from the front end. The front end does not have access to the database. Yes, there are a few DBs on the user's browser, right? The DB, it could be local storage, could be website, it could be index DB, and then stuff like this. But then it's not where we save cookies. And so don't save, when the user tries to sign up on your system, he wants you to save his details in your own database. That way, the person can be able to visit with his phone or a different browser and provide the email and password so that you can be able to do this is the person on the call. So if you're saving it into IndexedDB or local storage on the user's system, so what happens when he visits with a different system that is not that, so you cannot be able to know this is the person. And then the person will be like, this username and password does not exist and stuff like that. Avoid that. So you save everything on a DB, right? A DB is connected, or it's connected. Let's just use that. The back end is a DB. The API layer is the back end, but it's what the front end connects to. So this is all here we're trying to connect here. So third option, you could do XHR or XML HTTP request. That guy is over 18 already. That guy can mess up with your brain. For the sake of live and everything, please use fetch. There are many different options, right? Asios and like really great stuff. I think Vue has an HTTP component. Angular has also. React does it, right? React is a library. It's a front end. It's a UI library, so you still need to use either Asios, stuff like this to. Is basically what we want to do here. API call means you need to call the API, means you need to connect the front end to the back end, and that is what happens in this line here. So doing a fetch. Fetch is a JavaScript function that really does XML HTTP request, but a better way. Basically doing a HTTP request. So this here, you're trying to do a HTTP request using the fetch function, and you need to provide the path or the address of where the backend is, address to where the authenticate user does what they want to do. So, and if you provide path here, when you provide the fetch function takes two arguments. Yes, the first argument is compulsory, the second argument is optional. So you don't need to provide this, but in our own case here, if you don't provide this, you're going to assume the method of request you're trying to do is a get request, right? So if you're doing a get request and then you need to provide parameter and stuff like this, you can simply just use the path and remove this part. But when you're doing stuff like put, probably you want to update the user a patch, basically to update something in the DB, or you want to create something in the DB, or to try to confirm something from the DB, and you want to do a post request. Basically, HTTP has, we could argue, 4 to 5 different methods, right? Or you're doing a post request to create a record, a get request to fetch a record, a put request or patch request to update a record already on the DB, as well as a delete request to omit something from the DB. It's basically, mostly it's 4, right? Put and patch could be assumed to be like the same thing, where you're basically doing an update and stuff like this. So when you're trying to do this, anything other than get, please specify this parameter. It's an object. It takes, if you have, if you're expected to send a token and stuff like this, you add it to this pad. Method is one of those really important. Specify what you want to do. So we're doing a post because we're trying to get, we're providing these two. I guess I will have just used JavaScript object here and pass the body as an object instead of using template retrial. Well, I didn't think of it, but that's basically how it should be. And then once the fetch is completed, then we wait for a response. And in this line here, we're trying to convert the response into a JSON, right? Easier to work with than whatever you possibly want to expect, right? No XML, no please, and stuff like this. So when we do this, then we expect a result. So once this is converted to, the response is converted to JSON, it gets passed to the next line or this next line. This is where the success part is the failure part. If something goes wrong, it gets sent to this end. If anything goes right, it gets sent here. Right may not necessarily be right, it may not necessarily be wrong. Depends on how you look at it. So we get 200 requests with a status of 200, 201, anything around 404, even 501, the 400 series and 500 series. Definitely we get them in this part, but 200 will come here, and 200 doesn't necessarily be like what they're expecting. Depends on how the backend engineer built anyway. So basically that's what happened. So this line here, this fetch request is basically what connects you, the front end, to the back end. It's how the request happens. So if you don't know how this works, this is what it is. Or probably other options. JavaScript fetch is the preferred option, it's the go-to option, the recommendation. It's just making things a bit better. It's still fetch in the background, but doing basically some additional stuff that were not the fetch component itself, and it was being introduced. So And basically, we expect once the result, do your magic, show the user on the front end that okay, this is successful or this and stuff like this. It's how things work. And yeah, catch. If there's an error, send it here. Show the user on your dashboard, or you can console an error, or probably your DB and stuff like this. It depends on you, not your DB. So log it to your own screen, to the user screen. If you're using it for that's in development, right? Log into your screen console, as well as show a clear message on UI, and then show a developer-friendly message on the console. Like I expect the backend to be able to have logging already implemented to be able to okay, this field, this pass and stuff like this. So this is the front end to connect to the UI to the back end. And then let's look at what back end looks like. Not really much of it, but we're going to look at how the architecture works, and then we'll go back to a couple of things. There are a lot of things in the back end. I didn't cover here, but there's a reason. And then I have a page I'm referring you to that explains, that lists out most of the things. So, but what's the back end? We look at that shiny front end part. Now, what is that? Not really shiny, but not ugly. I won't say it's ugly, but it's not shiny, if you know what I mean. Something in between shiny and ugly. Not really ugly anyway. Something so yeah, so this is what it looks like. Yeah, these are some of the tools, these are some of the languages that I use to build what do you call it? Forgive me, I just picked this image from the internet. I was trying to find some tools, some programming languages I use for backend. These are kind of some of the popular ones, but something is missing. There is something very important. Java, for example, is missing from this image. Or I could see, like, but basically, just let's look at this for the sake of this call. But just get to know that there's Java, there is C#, there is missing ASP.NET. Okay, yeah, there could be C# and stuff like this. Yeah, we have Ruby here. Yeah, we have Python. We have Node.js. I don't know why we still have JS here. I'm wondering. Must be funny. Yeah, and we have this guy here. We have Ruby, we have Golang, and stuff like that. Yeah, these are some of the popular tools, some of the popular languages that are being used. Even though you could probably see from this image, you could see, oh, it's more of like language to learn for backend in 2020. So you could argue Java is less, not really less marketable. It's still a very secure platform, but people, I think, depend on where you're coming from. Some companies still use Java for their backend. Spring Boot is nice. Java EE have written some of these, like some of these frameworks like in Java some years ago. Like basically, these are some of the popular ones. PHP 6, especially when you're in Nigeria, especially because of the fact that I think shared hosting and stuff like this not really best for every app, but it does what it does. It serves the users that want to use it and stuff like this. Yeah, Python, you could probably go Django or Flask. These are some frameworks that makes writing Python on the back end easy and possible. JavaScript happen to be like one of those guys that happen in the front, happen in the back end, and happen in like literally anywhere. Or you can see it here. It disguises itself and has a name called Node.js here. Basically the name of a runtime that makes it possible to run on the server. PHP, yes, big choice. Ruby, more like Python's sibling. Syntax look closely alike and stuff like this. Golang, really great languages, really great language, really great syntax. And I'm not saying this because it's built by Google. Probably one of my preferred languages because it has less syntax. I love to do more with less. I'm not a fan of writing 10,000 lines of code just because I want one thing. It's the same reason why we broke up with Java and stuff like this. But like, this is what it is. So you want to learn, or you possibly use one of this, right? Well, let's look at the anatomy of what the back end looks like. So I'm assuming this app is built, the app that tries to authenticate user is built with JavaScript, basically with Node.js, right? So when a user visits the user browser, it could be, like I said, it could be a web browser, it could be a mobile app, it could be anything around that tries to visit, tries to connect to the back end. It does that via a protocol, a HTTP protocol. Like, if you can remember, if you can't, I'll repeat myself. This is the protocol could be you doing you're doing any of the operations using either put, post, get, or delete, right? And then you try to connect to the system. The app gets to connect to web server. Your request connects to the web server. The web server finds the environment, executive environment. In this case here, since we said we're using JavaScript for the back end also. So this is Node.js, right? And the Node.js itself, probably the app wasn't built using Node.js itself, because like that would be really, really hard, and like you could probably argue that could be hardcore. But like most times you use Express.js. It's a framework of Node.js that makes building web servers really, really easier. Even though you could possibly argue that this itself still has, Express.js itself still has some frameworks, Core, for example, Sales, another example. And the Node application basically houses a couple of things. The logic of the app, the middlewares in the app, probably things you want to do, or you could probably look at it from down up. So you visit a route. In our own case here, you remember we said in this part, we said we're providing the path to the API. So the path is a route address, and then the route checks middleware and be like, okay, is there something, do we need to log when this user tries to visit this website, like tries to visit this part? Or if they don't need to log, the middleware pass to the logic goes and find, okay, what is this person trying to do? So imagine in our own case, we did a post request. Imagine there is a post that tries to get authenticated, a post request, a post route, a user route that does that handles all post requests to authenticate user, and then checks possibly in the middleware. We could assume there is a login system that logs, okay, a request by this person at this time, and then the logic says to be, okay, what is this person do? Fine, the person is trying to do authenticate a user, right? If the person provided an email address and password, yes, we verify. Everything happens in this logic part, right? The application logic part, which could be probably further broken down. I don't think the call is supposed to be explaining how backend works. So this, I think, this is a good explanation. Like, this is okay for this explanation, right? The application logic will have controller different and stuff different, but like, let's assume this is what it does. The logic checks, you have the required parameter, it takes the header for the parameter, email and password, find out, okay, yes, it exists, right? It has been passed, and it does a check on the DB. So it just does a connection. It connects to the DB itself, the DB server. So in our own case here, we're assuming you're using an Express app that depends on your MongoDB, a Mongo database, right? So like I said, this is really the back end, and this is like the middleware between the front end and the back end. And we're assuming here is the front end and here is the back end. This is the middleware. This connects to the back end, the driver here. And then it here, remember the logic was to authenticate user. It asks the DB, hey, I'm looking for a user with this email and password. The email and password has been provided in my as part of the request, and I'm giving you check this message. There's an email and password, and then it gets the email and password. The DB gets the email address and password, and find within its record in the user table to be like, okay, yes. If it finds email and password, it returns the email and password details to be like, yes, this user exists, and this is the person's display name or username or profile picture and stuff like this, and then just send it back to the user. I send it back to the Express app. The Express app sends it back to the browser, right? So this is basically how it works. You make your request with the right protocol. It basically meets the right route. The route checks everything and finds the logic. The logic connects to the DB. Checks if what you're looking for is actually in the DB. And then if it finds it, if it doesn't find it, it returns a response to the logic. The logic uses that same route and send it back. It's basically a case of back to sender. Every single thing is actually back to sender. It's a handshake stuff. The person sent the first handshake. This person accepts that, okay, yes, my server has agree. What do you call it? My server exists. And then the person sent the message to hit this. This sends everything to this, and everything gets back the same way. And then this also does a handshake to be like, okay, create, like, check the DB. Is the DB connected? It's yes, I'm connected. Do you have these details? Yes, I do, or no, I don't. And the person sends it back to this side. Sorry. So that's how the back end also works, right? But like in between this and this, there are a lot of things that happen, right? If you're interested in back end technologies and you don't know what are the things that you need to learn and stuff like this, I intentionally did not add this, but it's a very, very nice part of this app. You could probably check out this website, roadmap.sh, and then you can go to / backend. So it's going to bring you this. So you could see we were using JavaScript for our example. So this here tries to tell you the languages you can use for backend. You can see Java is here, C#, PHP, Ruby, Python, JavaScript, Go, and Rust, right? Even though in our case here, just as this site recommends, we're using JavaScript for our example. I forget about this. Really important, actually, version control, be able to work with people in the team and connect. And then this language here is expected to connect to a database, right? People's preferred option most times is a relational DB. The recommendation here is to use PostgreSDB, SQL, very popular, MariaDB, Microsoft SQL or Oracle. But in our case, we did go with relational. Example here uses MongoDB, which is one of the non-relational DB. Really, really large support and stuff like this. So it's what we use, right? There are great ones, CouchDB, sorry, or RatingDB, Demo, and stuff like this, right? And then a couple of things that do intercept in the middle. ORMs are basically makes doing request to DB easy. It's easy, right? Once time and stuff like that. So that's not what I want you to. Yeah, so when you're learning to build APIs, right? REST APIs, JSON APIs, SOAP, REST, SOAP are some things that we get to know how authentication works, because our example here uses authentication, right? We didn't show you what really happens, like how to set up all, because this is not a backend session. Basically how authentication works. You should know how it works. Check email and password. If there's back, if it doesn't exist, send the response back and tell you, okay, this doesn't exist, right? Talking authentication, remember I told you we're doing a first request. You possibly in the second parameter, the object could take stuff like token to be able to authenticate and see, okay, this user works. This user is actually permitted to do this operation and the JWT ourselves. Yeah, and like I think the most important thing here is in between the front end, back end, also in between doing a request in the API layer, right? There's this here. Catching really works. Not every time you have to go and hit your DB. Sometimes you could do requests that are often repeated, could be saved once the first has been completed. It could be cached using either Memcache or Redis. Right? The recommendation on this side is to use Redis. as your DB for caching. So TDN client-side caching really works. It still works, but definitely server-side caching with Redis or Memcache, really great. There are a couple of things to learn here. Let me look at what is most important. Example, yeah, architectural patterns depends on what you want to use. And then if you're building a monolithic app, everything, both the front end and back end, it's basically the same app. You're deploying just one app, right? It houses the front end and back end. It's basically what a lot of people who use PHP use. Build a very huge monolithic app, write the very angry, like write a very crazy syntax, puts PHP code inside HTML, really ugly kind of stuff. But yeah, still people do monolithic, but don't still put don't necessarily put what do you call it? Don't necessarily put the PHP tag inside the HTML. But most times it's what beginners do, and like very annoying. So monolithic apps or microservices where people build different APIs, multiple APIs using multiple different languages and deploy them across different servers. That way, if one part of the app fails, the other part could still work. For like, I think a clear example could be if you use WhatsApp, and I don't know if you tell me you don't use WhatsApp, I'm going to be surprised. There are some situations, and I think in the past we've seen a case whereby this app or probably images on WhatsApp are not loading or don't download, but then you could send messages and stuff like this. Possibly it's basically because the microservice handling images or statuses was down. It hasn't been able to show it's not able to download and stuff like this. So service-oriented architecture, another great one, alternative to this. What do you call it? Bank software by to actually check back what is happening. CQRS is something you want, or event source is something you should be able to look up to. Something you could learn. Serverless, if you've used, for people who use Firebase, use other providers serverless platform. Basically, you write the front end and don't need to worry about back end. It's actually one patterns like that people use. Firebase is what I mostly use for this. AWS have Lambda and stuff like this. Azure have their own. And design patterns, definitely look at Solid. Basically, these are design patterns you should know. It's cool. Probably keeping it stupid, like simple to do. Or Solid, ensure. These are basically principles. So you definitely should read them up, understand. Dry, do not and stuff like this. And then if it's something that you need to search, you have a lot of record you need to search, please check Elasticsearch or Sonar and things like this. There are message brokers, do different things, RabbitMQ, Kafka. You want to deploy your app, you want to rise, check out Docker and stuff like it. There's also GraphQL and stuff like that, and other GraphDB and stuff like that. So it depends on what you're building. But most important in this presentation is to understand how things work, how the bootings connect to each other. So somebody back and built this, another person builds this, and uses this line of code to be able to connect the front end and the back end. The back end connects the front end based on when it's deployed, and then the user is able to do a request to the route that corresponds to what is in the DB. So that's how everything is connected. Somebody else can build one part, the other person can build the other part, and then everyone gets to connect. Once this person, the person in the front end tries to do this request, right? It's basically how things work. Really great to have explained this. Like I said, if you have any question, I'm going back to the chat section. If you don't have any question here and you possibly want to ask me later for more details, or probably a bit more of an explanation, I could share some links and stuff with you. Send me a DM on WhatsApp, or I said on WhatsApp, a DM on Twitter. This is my handle, OwlMS. and I'll do my best to respond to you as fast as I can, right? I may not necessarily be online when you're sending the chat, but I'll do my best to answer any question you may have that has to do with how these things are connected, or you have questions around back end or front end or architecture and stuff like this. Thanks for the opportunity. I'm going to the chat section to see if there are any questions. Else, we hand over to the event organizers.
No, thank you. The chat, so if you can kindly go through, we appreciate that.
Yeah. Okay. So yeah, thank you. Yeah, I'm seeing some questions on the chat section. I could probably answer one or two, or probably answer all with the easiest explanation I can do. So first question here, question from audience: when integrating back end with front end, where is JavaScript native fetch not preferred? It's basically preferred, and people do go for libraries like Asia's. Different people have different things. Like when you want to do something as simple as you want to do a you want something to happen when you click on a button. Somebody can wake up in the morning and come and bring people actually bring Ajax, add the whole of jQuery 160 kilobyte to a page just because they want to do an Ajax request. And even when fetch came, people felt, oh, it's not doing something I want. No, I don't just want it to be promisified. I want it to do something or something else. Like basically, yes, Azure is a very nice library, right? It has a few additional properties that you don't necessarily need, except if there's a use case, right? Fetch covers most of the needs of doing backend. But if you have special requesting Azure's has, it's why it tries to solve a couple of things that are not available. Probably raise you want to do multiple requests, and then once everything finished comes back. I know people promises like and I resolve them at the same time, but like most times people use Azure's because they want additional stuff to it. What is cost? Cross-origin resource sharing. So cost is when what is stopping me from connecting front end to back end? Yes. So cost is basically you trying to enter my house without my permission, right? Yes, you know where my key is. So beside the fact that I have a key, I know where the key is. I still want to be sure. I need to give my key the permission that it has to come from my hand. Most times it's a back-end issue, right? There's usually needs to be a middleware, and then this middleware usually say, okay, enable cost, but allow it with request from say this specific URL. So if you're coming from a different URL, oil for you, right? It's basically going to be oil for you. It's going to be keep rejecting because it's expecting something and it's not getting that, basically because the developer ensured that, okay, you need to be able to provide this or this. Either the authorization token, you didn't complete that and stuff like that. It's why it costs. Most of the times it's because it's missing, there's something missing. Except in the case where the back-end developer forgot to specify this. So small Fred said, I think I'll prefer Azure because I don't have to worry about a sing and await keyword, and I'll leave how I should segregate the response into various data and header. Yeah, so exactly, you see what he's saying. He said he prefers. It's not like it's the best option, right? He prefers it because he's too lazy and he's too right async and await. Don't mind, it's just a joke, right? It's just a joke. Don't worry. Yeah, he doesn't want to write async and await. He doesn't need to worry about that, and he wants everything segregated. Yes, first still sends this, but like he wants to see what is in the header, what is in data, and stuff like that. So people want additional things to what is already there. It's basically why they use this. In determining, so moving to the next question, in determining stuff for backend, is it best to go for a pure language like? There's nothing pure about any language, bros. For a pure language like PHP, or a runtime language or framework like Node.js and Laravel. So let me try to be nice. So instead of you to write, for me, right, preferable than for you to write PHP, please go and write Laravel. Let's move in peace. Or check out Slim and many other frameworks. Like try to cut out the security issues and stuff like that. Runtimes could probably compare to native languages, or probably there's actually nothing like native. There's nothing pure right? PHP is a language. Yes, you could argue Node.js here represents JavaScript, which is also a language. I know it's a runtime, but it depends on like literally everything PHP depends on. If you think PHP is a pure language, you cannot run PHP if there's no Apache on your system. If there's no Apache on your system or a server, the reason why even you're able to use shared hosting is because there's already Apache installed by default on the system. So let's not kill ourselves, right? It's just pure life. All of us are pure. Nothing is impure about it. Frameworks, yes. Compare Laravel to Express and stuff like this, not to Node.js. We don't want to start war. Let's end SARS and live in peace. Be cool. So yeah, depends on what you're trying to build, right? When determining stack, it should be based on what you're trying to build. If it is something that is CPU intensive, please go to languages that do that most. Yes, PHP is one of PHP is one of those. You could check out Python, you could check out Ruby and stuff like this. If you're doing something that is more of like a real-time stuff, maybe you're building an app that has to do with chat and stuff like this, Node.js is event-driven, really a good choice. I'm not saying Node.js is the best choice for every app, right? No, it's PHP the best choice for. The reasons why people usually build apps with microservices is because you want to use different languages to build one app. So you can build the chat functionality of your app with Node.js and build the e-commerce or possibly other stuff related to that with PHP. You could argue, okay, Wikipedia is built with PHP. I could also argue that Netflix is built with what? Or you could say probably yes, Slack is built with the back end. Well, you're using Netflix and Netflix is built with Node.js. So everyone wins for what it's best used for. What are the different ways to perform authentication? Like there's actually no different ways. There's just one way of doing authentication, to perform authentication. The user should provide what the person knows as the credential, either the phone number, the email address, the username, or whatever, and then a password, something to authenticate. If you're doing no password, you want to use the magic key. So the person provide an email address or the username, and you send the person a token or probably a password, a one-time password to their email, and then they enter that and it works, and then the password gets disappeared and stuff like this. People do say token is the best way to authenticate. Yes, token is nice. When you do a request, right? Even when you do email and password, most of the times the backend is supposed to add a token, send a token as part of the backend to the user, just so as part of the response to the user, so the person can be able to save. The next time a person wants to do sort of an action with that using that same using as that same person, the person doesn't need to log in. The person just need to provide their token. So which must have been part of what you've already provided to on their system, or you saved your own end at the back end, right? It's basically what it is. Yes. What is Google Auth 2? So imagine you visit a site, and then you want a user to log in. I don't want the person to create a username and password. You just want to know if the person is saying it is. The person you could provide Google Auth 2. Basically, you want to log in user using their Google credentials, right? Depends on you. Is Firebase better than developing full-fledged app? I am not in this war. No, it didn't happen that way. I wasn't here when you asked this question. Firebase is good for what you want to use it for. You want to build an app and you want it to be fast, you don't have a backend developer close, or you want to build an app and you think you don't need some special attribute. Yes, you can also use Firebase for whatever you want to build. I don't know, depends on you. Check the use case, see if Firebase will be able to solve that for you and use it. It's a nice tool. I use that for backend. Yes, I still build my APIs most times. And even the fact that I use JavaScript for most of my stuffs, I still am able to extend Firebase by adding cloud functions to do like some things that ordinarily Firebase doesn't do, like send email to users once they try to log in and stuff like that. So Depend on what you're trying to use. Check it if it's a use case. If it's something you think you want to build, you're probably expecting large user chunk and think, oh, I want to create a custom experience for users. You can build your own back end. But if you think Firebase will solve what you want to use, please use that. Last question here. So how can I make my HTML, CSS, and JavaScript live? Like that's basically using something called hosting. You need to host your platform. Firebase give you that option. Netlify give you that option. GitHub Pages also does that for you. There are many different options. Surge, and a couple of things. I can see it's on my web system. Other people cannot see it. People cannot see because it's on your system and cannot be seen. Your system is not always going to be in the internet. So when you try to check out, you can Google search Firebase hosting or GitHub hosting or Netlify hosting. Host it there. They have servers that are running 24/7. People can be able to go there. So they give you a URL. When you want somebody page, you send a person your what do you call it? Your website address, right? And then when the person click on that or goes to that address, the person gets sent to the IP address where your code is being hosted, and then the person gets to see what you usually see on your screen. It's a long process. This is not why the session is, but it's basically an example of one of those things. So hosting is what you're trying to look for. Oh yeah, Vatal too. Great. As a beginner who is interested in backend, what languages do you suggest to learn first? Just from your professional point of view. Well, we could argue this from today till the end of life. My preferred option is going to be Node.js. Node.js is because from your initial question, you already know you've built HTML and CSS, right? And I'm going to assume you're able to build JavaScript. You're going to use JavaScript in your front end. So use your language, the knowledge you know from JavaScript, and go to Node.js, right? Node.js, you're still going to be writing the same JavaScript we learned in the front end, but this time around, you're building it for a different, targeting something different. So the syntax remains the same, but then how you're writing it is going to end. So, but yeah, whatever works for you. Oh, no, so you don't need to be worried about the confusion of what to learn, right? So like, it's the reason why I shared this link, roadmap.sh. It's still on my screen here. I'm not sure. Let me try sharing my screen one more time, and then we end this call in a minute. So you can see here, so when you come to roadmap.sh, go to /backend, or let's just see, this is what it looks like. So when you come to roadmap, you come here, front end guide, back end guide. So let's go to the back end, because that's where your question is. So we're at the back end here. Let's wait for it to render. Don't worry. I've been running away from different locations. I don't know. My letter is just being funny. Yeah, so it has loaded. So for the back technologies, we assume you'll understand how the internet works, what is HTTP and stuff like this. So the question is, what language do you want to learn? So the suggestion from this website is for you to learn JavaScript also. So Node.js basically. So you learn the basics of Node.js. You just go to nodejs.org. There is a good explanation there. Or even when you're reading Node documentation, it will tell you, please go and check out Express. Basically, it's a framework that makes things easy. So you learn Express, not just an Express. You get to understand how to build this. There's a lot of resources on the internet. YouTube houses like a chunk of it, right? You learn about Node.js. You then in the long run, you learn about how to integrate it to DB. You need databases, MongoDB or whatever choice. You want to go to Postgres, MySQL, and stuff like this. Depends on what works for you. But my recommendation is Node.js because you basically have learned JavaScript in the front end. So use that roadmap